Good morning, everyone. Welcome to our first Hackster Impact Spotlights event. If you might have joined us before for an Impact Summit in 2022 or 2023, and if so, welcome back. We've got a new format for you. We're shifting to focus on highlighting more of our Hackster community members and the tech that they're using to build a better world. So we've got 4 presentations for you today on the theme of smart agriculture, brought to you by Nordic Semiconductor. This is going to be a free monthly virtual event, just like today. And so you're going to see a couple of follow-up webinars have also been scheduled around this subject. You'll see a couple of quick previews of those today as well. And we've got 4 presentations for you, as I mentioned. You're also going to hear more about our format from our new-ish director, Ben Strahan, in just a moment. Yeah, so we'll also be sending all these links out to both the projects that are featured today and to the webinars that you can sign up for, and also to where to submit your projects for future month's themes, which have already been announced. Talk about that at the end of the session. But you'll be able to submit your own projects for those here. But don't go there just yet. We're about to start in just a second. Here is a quick message from our director, Ben Strahan, about Impact, the new format, and what it means to us.
Hey everybody, welcome to Impact Spotlights. My name is Ben Strahan and I am your new director of Hackster. I wanted to take a moment to welcome you to this event and explain a little bit of what Impact Spotlights is and what it means to us. So every year we host an event called Impact. Recently it was called Impact Summit. And after each of those events, we have a retrospective like most of you have at your office of was it effective? And we measure ourselves in 3 areas. Did we do all that we could to feature the right projects that are bringing in the most innovation and impact? Are we doing what we can to bring attention to the initiatives and the efforts of our partners? And third, and most important, are we actually making an impact with sharing this information and driving the initiatives of sustainability forward? Well, when we asked ourselves these questions, we came up with something unique this year. We decided that one event each year was not enough. We could do more. There's more opportunities, more innovation, more projects, and more initiatives that we need to bring attention to on this platform. So with this, I want to welcome you to Spotlights. It's a once-a-month event that we're going to be hosting where we pick a specific topic. This one, the first one, is with agriculture. And we bring innovation forward and conversations around that specific topic of sustainability. So I want to thank you so much for being here. I want to thank for every speaker and innovator that has participated and has agreed to talk today. And I really want to thank the community in general for supporting us, impact, and sustainability and making it part of your life. One of the things that I want to bring attention to you is we can't do this and we can't keep the lights on and we can't run this platform without the support of our sponsors and partners. So I want to thank the 2 that we have today, Nordic and Microchip. They have efforts in sustainability and in smart ag that they're going to be talking a little bit about. And if you find it interesting, they are going to have following events that you can go to throughout the week and months to come. So again, thank you so much for being here. I look forward to the talks. And I hope to see you again every month. See you later. Enjoy the show.
I love that video. It's so good. All right, so maybe that's a little self-aggrandizing on our part, but isn't he Ben great? Ben, everybody. So our first couple of spotlights feature a robot dog that assists with watering systems using AI and an AI system for counting bees, helpful in both beekeeping and ecological studies, and it's powered by a Brazilian single-board computer, which I think is pretty cool. So let's check out our first couple of features. Let me make sure I've got the right one. Here we go.
Hello everyone, we are Barolo team, and today we'll present you our project Fresa. But wait a minute, isn't Barolo wine? And Fresa is a wine too, so what's going on? Well, Gianluca will explain it for you.
We are a small group of friends who work or have previously worked for an Italian company headquartered in Piedmont, a region situated in the northern Italy region. On top of that, Barolo is also an iconic wine that originated in Piedmont. Our goals are: have fun while learning new technologies, contribute to open source, share the knowledge for both personal and professional growth. You can check our project at github/Barolo. After taking part in the OpenCV Special AI competition in 2022, we decided to try again in the OpenCV AI competition in 2023, bringing all the previous knowledge from the Arnaise project and adding more people to the team. Here today we'll have some of the members of the Barolo team that participated in the FRESA project. We had to collaborate with individuals from various cities and even different continents. As meetings piled up and ideas flowed, we faced the challenge to decide what type of project we would undertake, which robot to utilize, and the specific terrain in which it would operate. The choice of the terrain was not limited to the type of ground suitable for a tracked or wheeled robot versus one with legs. It also involved selecting the appropriate plants for the project recognition system. This consideration was crucial, especially given the time of the year when we could capture the necessary photos and videos for our demonstration. We also had to design a sprinkler that would be fitting for the selected robot. This collaborative process not only enriched our discussions, but also helped us refine our vision and ensure that our project was both innovative and practical. Once these issues were resolved, we needed to evaluate the hardware at our disposal for the recognition task, as well as the platforms on which to run it, along with the software required for our project. This step was essential to ensure that we had the right tools to effectively implement our ideas and achieve our project goals.
Thank you, Gianluca. But now let's talk with Eric Orso, who will explain us how this robot has been managed to be driven.
Hello, I'm Orso Eric, and this is Mini Pupper. This is a quadruped robot. It is meant to move like a dog. It has 12 degrees of freedom, 12 models. It has hips, it has knees and shoulders. It can do all the range of motion that a dog can do. For this project, we needed to add extra degree of freedom, like one here that controls the pump, that control the sprinkling. In order to simplify attachment of motors, we developed Lego attachments. So right now we can use Lego to extend the capability of our robots. It's all open source. Currently it is remote controlled through a web interface, but there are several things we are exploring. One is to use ROS, the robot operating system, to navigate on a map. This is already implemented in the open source project and should be easy to try. Another thing is to use artificial intelligence, so having like a speech to text and an LLM to move the robot. This can be done two ways. One is through the cloud, so interrogating a model on the cloud. Another is with local inference.
Thank you, Eric. But now there is a tricky part. We'll talk with Davide, who will explain us his machine learning models that recognizes plants and their issues.
The machine learning models are the center of our application. Indeed, they are the way through which the robot is able to understand its surroundings. We decided to use two separate models to perform two distinct tasks. The first one is a plant detection model, which basically allows the robot to find the plants in its field of view and to determine the direction to follow to get closer to those plants. Once the robot is close enough to the plants, it will switch to a different model, which is instead used to classify the leaves. So this model will help us in determining whether the plant is healthy or unhealthy, and if the plant is unhealthy, we will trigger the sprinkling mechanism to provide water. Both models are based on the YOLO V8 architecture, which is a state-of-the-art neural network architecture for one-shot object detection. And they both have trained on custom datasets, which have been built thanks to RoboFlow, which is a nice platform to gather a huge number of images and to create datasets to train models. Initially, in our initial implementation, the models ran on the OAK-D Lite camera by Luxonis, which was connected through USB to the robot. However, as we keep on working on the model, on the project, we are trying to experiment with different types of hardware, specifically with cheaper options to run the same models. Right now, we are trying out the SenseCap Watcher by Seed Studio, which is a Kickstarter project right now. So it's also a new type of device, which basically is a AI assistant which has a camera and it's able to understand the surroundings. And it's also good for running our models, so we believe it has a huge potential.
Thank you, Davide. But now let us brag a bit about what we have done in recent times. After we won the first grand prize at OpenCV AI Competition 2023, MakePipe magazine wrote a paper about us on issue 139, and also Tom's Hardware wrote an article about us. Then we managed to continue to develop our project and our machine learning models and our STLs that you can find on GitHub in a backdrop build and older versions in which we come up as finalists. And we want to thanks again Brownpod for the funds they've given us, and also Seed Studio, with which we collaborated recently with the SenseCap Watcher. Actually, you can check it out on Kickstarter. It has just come out and we managed to try it before it's launched. So, what's going to be in the future? What's going to happen? Well, we have Gianpaolo that will explain it for us.
Wow, it was a long trip of the last few months, but the journey is not over. As Gianluca pointed out earlier, our team is open to anyone who has the desire of learning and having fun. Just go check on GitHub our projects and submit bug reports or propose features in the issue tracker. And if you have never contributed to an open source project earlier, we have suggestions. In October, our team will act as maintainers in the Hacktoberfest 2024. So we hope to repeat the same experience we had last year with many contributions all over the world. You can start looking at some projects of our team and look at the issues with the Hacktoberfest label, and the maintainers will help you going through your pull request and having it merged. We did the same with other projects, like we just submitted a contribution to Space Ross on GitHub. But if you are not ready to contribute directly on GitHub, just go check and follow us on Instagram or X. We are Barolo team on both. So you will be the first to hear about the progress of Freysa and the other projects of the Barolo team. Last news, in early October, a couple of us will be mentors in the NASA Space Up Challenge. So go check and possibly join. So where our Freysa robot dog will ever go? As someone says, the sky is the limit. Bye.
Hello everyone, my name is Anderson. I'm a master's degree student from the Federal University of Itajubá, here in Brazil. And with the help of my advisors, Professor Marcelo Rovai and Professor José Alberto, we're exploring a project that involves technology and nature in the field of smart agriculture and sustainable farming. Together, we're developing a project to estimate the number of bees entering and exiting a beehive, which is a crucial task for beekeeping and ecological study. The title is The Use of TML for a Non-invasive Beehive Monitoring System. Well, in our project, we use a Raspberry Pi 02W, which is a powerful edge computing board with 1 GHz quad-core CPU and 512 megabytes of RAM. We had to increase a little bit of this RAM size in order to our model work better. We'll talk more about this further in this presentation. And inside the Raspberry, we ran a module called YOLO V8 from Ultralytics, which is a real-time object detection module and offers a very good performance in terms of speed and accuracy. Let's talk about the importance of bees. Well, bees are very important to us. The most important factor is the pollination, because bees are the most common pollinator. And the work of the bees are crucial for the reproduction of the plants. And also bees help the humans to ensure the sustainability, and at least 1/3 of the food production depends on bees. Also, bees can provide us with some important food like honey, like beeswax and propolis and others. And in some rural communities, bees are a very important source of income. Okay, so to start our project, we had to create a data set. In fact, the data set collection is the most critical phase of the project and should take weeks, even months to be created. And we asked permission for a beekeeper to take pictures of his beehive. Here's some examples of the pictures. Well, after take the pictures of the beehive entrance, we used a online platform called RoboFlow to label each bee on the picture. This platform helped us a lot, and with the auto label function inside the platform, we save a lot of time because they perform a auto label for us. Of course, we have to work on some pictures, like some of them wasn't marked, and we have to manually mark the bee, but was a very good platform for us. After labeling all the bees in the pictures, we split the pictures in groups for training, validation, and test, and we was able to export the dataset in a YOLO V8 format. We had two options. We was capable of export the zip file of the pictures with the bees marked, and also we have the link to download directly from our module. Well, after that, we was able to train our dataset. We import all the dataset that we created on a RoboFlow, and we perform a training. Here's a picture of our model during the training phase. We use a Google Colab, and we use a Jupyter notebook to create the model. Okay, so this is the training results of the model. The model took around 2.7 hours to be trained and showed an excellent performance. As you can see in this picture, the majority of bees was marked on the screen. So this shows us how good our system is. The next phase of the project is to install YOLO V8 inside the Raspberry. and put the raspberry with the camera connected in front of the beehive entrance in order to estimate the number of bees entering and exiting the beehive. First, to install a operational systems inside the Raspberry, we decided to use a light version, and we did a memory swap by separate part of the SD card memory to be used as a memory inside the Raspberry Pi. This is very important because YOLO V8 is a heavy module, and with the memory swap, the performance increased. After that, we ran a YOLO V8 inside the Raspberry, and as you can see in this test image, the YOLO was able to detect all the different objects in the picture. After that, we upload some image of the beehive entrance that we took before inside the Raspberry and ran the module YOLO V8 inside the Raspberry in order to see the results. And also the model worked very good. And what we really want in the end of this project is take pictures of the beehive entrance, like from 10 to 10 seconds, and perform an inference and estimate the number of bees in the beehive entrance and send this information to a beehive owner. So the owner will be able to know if the beehive is okay or if something is wrong without going to the beehive. That's our goal for this project. We can upload this information on a website or on an app, and the beehive owner can access right in his hand. So this is our project. Professor Marcelo Rovai has a lot of other amazing projects on his Hackster platform. Thank you, everyone.
Hey, Alex. Sorry to interrupt. Alex, you are muted. So
I am
we can't hear
muted.
you.
Hey, I
No
knew that would
problem. Just
happen.
wanted to jump in so you could say that. Sorry about that.
Thanks, Katie. Katie,
Oh.
everybody. She is an awesome member of the Hackster team. You might have seen her at previous Impact Summits as well.
Yeah.
It is early for me. Okay, cool. Thank you, everyone. I was just saying, thank you for jumping in the chat, in the comments. We love seeing your your reactions, and we do have our team members in there on all the different platforms, as well as I'm seeing some of today's presenters in there. Lovely to see you. And also we've got a couple of our sponsors in here as well. So speaking of which, we have those couple of webinars coming up that I was talking about, which tie into existing initiatives in sustainability and smart agriculture that both Nordic and Microchip are working on already. So we've got those webinars, which will be full of really interesting information, I think. And so we have a message first from Clay Hines of Nordic, who's going to tell us about their webinar, and then we'll have our final couple of presentations, and we'll hear a little bit more. All right, let's go.
Manager with Nordic Semiconductor. Nordic is very excited to partner with our friends at Hackster to hold webinars focusing on a few of Nordic's key vertical markets. The first of these webinars from Nordic Semiconductor will focus on smart agriculture. Smart ag is a new and emerging market that Nordic expects to be very significant, not only to the audience listening right now, but also to the entire world. Today, 1 billion people on the planet lack access to sufficient food. With this, and with the expected global population growth, in 25 years, we will need to grow 100% more food than we grow now in order to feed everyone on the planet. On top of that, virtually all of the land on the planet that can be farmed is currently being farmed. Smart ag involves technologies and implementations that address this issue and provide for more efficient methods to grow and distribute food, optimize yields, and minimize the resources that are used. Nordic Semiconductor is especially excited about the potential for the capabilities within our company to help support smart ag. As a world leader in wireless IoT and in low-power connectivity, Nordic is uniquely positioned to enable solutions that monitor crops, monitor soil, weather, irrigation, livestock, farming equipment, and an array of other farm systems. Through smart ag, Nordic can enable more efficient wireless sensing, gateways and access points with low power consumption and broader bandwidth, easy scalability across different sized farms with wireless mesh architectures, and more use of drones and autonomous vehicles. Nordic is the world leader in ultra-low power Bluetooth low energy solutions, and over the past several years has developed other industry-leading solutions in cellular IoT, low-power Wi-Fi, emerging technologies like DECT and our Plus, and in other short-range standards such as Thread and Matter. Our Smart Ag webinar will be at 9 a.m. Pacific Standard Time on October 23rd. During this discussion, I'll dive into many of the aspects of Smart Ag that Nordic supports, and I'll talk further about some of the unique challenges of the different applications in this market. This will be a live webinar, so there will be an opportunity for you to ask real-time questions and for some discussion. Thanks for watching, and I hope to see you all then.
Sweet. And I am not muted. So hey, remember, we'll be sending those links out over email after this event. We'll also be dropping them in the chat at the end of this session. So either way you choose. If you're not on the email list already, you can do that at our Impact Spotlights event page, which we'll also be linking. Be sure to whitelist impact at Hackster.io in your email client so that you get all of those, and that'll also be the place that you can submit your future projects. So next up, we have Farmery, which is a cool open source farm management tool which allows you to connect and manage wireless sensors, smart devices, and do task management and automation processes for farming. After that, we'll have our last presentation, which is AgriHoverGames. It's a smart drone that helps assess the health of vines via texture, shape, and color. So those are our final two presentations. Then we'll have a goodbye message. We'll also be hearing about Microchip's webinar, which is coming up, so stick around. All right.
And sustainable farming business. Here are our sessions in the presentation. First of all, we will discuss the challenges of sustainable agriculture now. The second, we show the current issue our customers. The third is what the solution we propose for the customer. Next, what is the value proposition of our solution? Continue, we will list the main features we are targeting now and also our team members. Next, we got some checkpoints on the journey, and we will share some testimonial projects we built for customers. Finally, we demo some main features of our solution. We met the agribusiness owners in my country and discussed so much about the new technologies that bring change to farming today. Also, we shared about smart agriculture solutions such as IoT devices, drones, AI, and machine learning. However, the main issue that affects sustainable farming is not technology, that is the human. All farmers meet the issue of finding the workers for their farms. The young people go to the city and work in the companies or warehouses. They can't find a new worker soon if any member retires. The big issue is if the retired member is the manager, how can they transfer the current tasks to the new member? Here is our case study. We have a customer. They built a greenhouse of about 2,000 square meters to grow vegetables and fruit for their resort. They hire a manager and 5 workers to handle the farming tasks. The manager has experience growing some vegetables for the previous organization, but she doesn't have any experience in personnel management. She needs to report the daily work to the owner, as well as divide the work and give instructions to the employees. And every day she starts with a series of questions. How to plan production to suit demand. What kind of crops have to be harvested today, and how much specifically? What kind of crops must be planted today? How much is the planting area? How is the work divided among each person today? What are the results of each person's work? Do the completed jobs meet the requirements or not? How to verify? Are there any problems that arise at the grower's house? Who handles the problem? Has it been handled or not? For imaging, if the resort expands the business, that is a terrible nightmare for both the manager, worker, and owner. Our team started an idea to build an application to help the customer transform their daily tasks and farming processes into digital data, and all actors can access anywhere and anytime to track their progress. We call it Farmery, an ERP app for agriculture. Farmery is an enterprise standard farm management application that helps farm owners easily manage work, manage personnel without spending too much time, manpower, and costs. Comparing the Farmery apps with the traditional management by paper, whiteboard, and notes, our app can cut down the management costs, maximize revenue, and increase the profit for the stakeholders. With Farmery, we don't focus on replacing the workers in farming. Instead, we want to transform the current farming skill and process on paper or the mind to visual data and replicate it for multiple sides when you expand the business. In this way, you can cut down the management costs, increase revenue, and maximize the profit for your organization. Farmery targets some main features, which are almost customer needs, such as process building to transform the current work to digital data, IoT integration to remote monitoring and controlling the IoT devices such as sensors and controllers for optimizing crop health, task management to assign tasks for members and get the task report anywhere, crop planning to control your farming resources better than before, inventory management to improve the order and business, compliance and traceability to track the issue happening in your organization as soon as possible. We are not only the first application for the smart agriculture market, but some famous commercial applications such as Artemis, Farmer, and AgriHoverGames. But Farmery is the first open application for the farming community. You can access Farmery as free. We also provide a customized version for the organization to install on their private servers. You can control your data as safe. Here are our team members. I'm Tan Du. My background is in software development. Mr. Kong La, project management and software development. Mr. Min Trong, business development. Mr. Tin Lai, hardware development. Mr. Bin Go, customer support. In our journey, we reached some milestones such as third prize in IoT 2017 in Ho Chi Minh City. The top 5 startups joined the innovation camp in Iran in 2018. First prize Singtel IoT Hackathon in Singapore 2019, and some medals from other organizations. And here are some testimonial projects that we built for our customers. Install an IoT device in the vegetable farm to monitor the environment and control the irrigation system. Install an IoT device in the melon farm to monitor the environment and control the irrigation system. Install an IoT device in the mushroom farm to monitor the environment and control the misting system. Build a smart container to control the environment and nutrients to grow the strawberry. Build an indoor growing system for the home to grow vegetables and flowers. Apply Farmery for the hydroponic farm to manage their process, and integrate the IoT devices for the hydroponic system. Apply Farmery for the lychee farm to manage their process, and integrate the sensor to monitor the soil condition. The nutrient controller for the greenhouse and hydroponic farm. The device can monitor the nutrients such as EC, pH, and temperature in the tank, automatically dose the nutrients, B, pH, and remote control the irrigation system on the Farmery app. The multi-channel controller for the greenhouse to remote control the devices such as the pump, lamp, fan, and misting system on the Farmery app. Soil sensor monitors the soil conditions such as temperature, moisture, EC, pH, and NPK. Environment sensor monitors the air environment such as light, temperature, humidity, CO2. Now we will demo some main features of the Farmery app. On the screen is the Farmery dashboard. You can grab the summary information about the crops, daily tasks and devices. The left sidebar is the menu for accessing features such as device, crop, task, process, storage, and settings. Device menu allows you manage and control your devices such as getting the sensor data, turn on or off the controller, accessing the historical data, adjust the sensor threshold or set up the timer for controllers. We provide many IoT devices suitable for your farming, including sensors, controllers, gateway, and camera. The process menu allows you to convert the traditional farming process to the digital process for easy management. You can define the detailed task for each process to help the worker and manager easily follow them, and you can get the task report quickly more than before. The crop menu allows you to manage your crops, such as how it works, how it is going, who is responsible for the crop, internal daily task reporting, fertigation, and pesticide data. You can verify and validate that the issue affects your crop health. Same as the web application, you can access all features such as devices, crop, process, task, storage, and settings on Android and iOS via Farmery mobile app. If you want to try the Farmery app, go can scan the QR code to access the Farmery user manual. Thanks for listening to our presentation. If you have any questions or want to cooperate, you can contact me by the above email.
There we go.
No
So
problem.
thanks, Kitty. Thanks again to the Farmery team for joining us and taking advantage of modern technology to be able to join us from across the globe. As a reminder, we have Hackster members all around the world, and so we're thrilled to be able to welcome them to present. So now it's time for today's final presentation, which is AgriHoverGames, the smart drone that helps assess the health of vines via texture, shape, and color. Let's take it away.
My name is Dobradan Marius. I am from Romania, from Gheorghe Technical University of Iași, and I am happy and honored to be here. In this presentation, I will show one practical application related to smart agriculture. The application was developed in the frame of the AgriHoverGames challenge organized by Hackster, a competition in which I participated in all 3 years of occurrence, a competition in which I took first place twice and second place once. This application aimed to detect and classify diseases in a vineyard. This application is based on a UAV system that was specially developed. The main idea is that there is a growing need for food worldwide, and this need requires the development of high performances, high productivity, and sustainable agriculture, which implies the introduction of new technology in each stage of plant development. However, many elements affect crop development, like the one presented on this slide. But one of the most important is the existence or not of the different type of diseases. In this project, I developed an intelligent system to assess healthiness of vines based on the characteristics resulting from the analysis of the vine leaves, such as texture, shape, or color. The intelligent system presented here is able to detect 2 different diseases. The first one is blister mite, which is generated by a mite species infecting grape leaves. This disease is also a vector for other viruses that affect vines. The treatment for these diseases should be applied when the first mite appear. If they are allowed to develop, they will do so quickly, mainly because this mite has between 5 to 7 generations in a year. The second detected disease is grapevine leaf roll diseases. This disease is one of the most important grapevine viral diseases affecting wine grapes worldwide. The main problem with grapevine leaf roll disease is that there are no ways to cure an infected vine, and there is no chemical control for grapevine leaf roll disease. Therefore, the only solution is to remove and destroy virus-infected vines. So, as a direct conclusions, the field survey and the detection of the grapevine leaf roll disease are the only valid approaches used up to this moment. The grapevine leaf roll disease is considered one of the most economical destructive grapevine virus diseases. There are many estimates of the economic cost worldwide. Some estimate loss range from 29,000 to 226,000 per hectare. In another estimate, the loss is up to 77% revenue decline. So, as a direct conclusion, this intelligence system is important because a timely diagnosis and accurate identification of the grape leaf diseases are decisive for controlling disease spread and ensuring the grape's healthy development. Moreover, the early detection of diseases will determine the use of pesticide only when necessary, with a positive impact on the environment. The UAV system developed was built based on the HoverGame drone kit, which is a professional development kit produced by NXP Semiconductors company. This kit contains all the required components needed to build a quadcopter, such as frame, motors, and flight management unit. The system incorporates a D435i deep sensor to guide the drone through the rows of vines. For vines planted industrially with mechanized soil maintenance, there is a 2.2 up to 2.5 meter distance between the rows, so we have plenty of space to fly. The Google Coral camera was used for plant anomaly detection. The intelligent detection system is supported by IMX8M Plus development board carried over the entire vineyard by an NXP HoverGames drone. The development board also has a neural processing unit on which the deep neural network is executed in real time. What is important to mention here is that almost entire system is based on open source software and hardware. By starting with the flight management unit, going through the Nutix operating system, which is in my case the base for the running of the PX4 autopilot, the Mavlink protocol, the ground station, the robotic operating system and Linux operating system, which run on the companion computer, and so on. At the level of the IMX8M Plus, the functionalities were implemented using the support of Robotic Operating System version 2. Additionally, a 0MQ client application and 0MQ server were used for debugging the developed application in real time. The HoverGame drone can fly autonomously, but based on a radio control link, the ground control operator can take control of the drone, switching from the autonomous to the manual mode. By using a telemetry connection, it is possible to configure the flight path, supervise and change settings and parameters of the flight management unit, and in this mode to check the status of the HoverGames quadcopter while it is in the air. Communication between the flight management unit and the companion computer was done by using an UART connection. The components that implement the software part of the UAV drone were developed as a single ROS2 package having 4 nodes. All the communication and synchronization between nodes were done through topics. The detection system is based on the TensorFlow Lite model and runs on the health plant node. The detection system starts when the UAV is set in the off-board mode. The node takes note of this fact from the flight control node through the flight off-board topic, and in this mode the detection process starts. The health plant node published 2 topics related to the detection process: detect vitis and detect leaf roll. These 2 topics post the area of the leaves for each class detected. This publication of the affected leaf area can be used to create a a real-time map of the extent of the crop damage. The flight control mode is connected to the PX4 autopilot, being able to control the UAV. It is also able to know the status of the drone at each moment. This node can arm, disarm, take off, land, etc. the drone accordingly with the necessities resulting from the off-board control. The video broadcast node can subscribe to a specific image topic and stream the image to the 0MQ video server based on the Wi-Fi link. Mainly because in this project I want to detect only two types of leaves, and because these leaves do not belong to the categories on which classical deep learning networks were trained, like person, car, airplane, bus, train, and so on, I use the transfer learning paradigm. So I use the MobileNet deep neural network, which is widely used for image detection and recognition. This neural network already has trained layers that can identify different features, like outlines, curve, edge, etc. So I used all of this already embedded knowledge and I only retrained the last layer. But in order to train this layer, a new training database with images from the two classes was created. 80% of the images from the database were used for training and 20% for testing. For the image annotation, model selection accordingly to the desired accuracy, model training, model optimization for efficient neural processing unit execution, and model validation, I used EAQ environment. Following the training process, the detection performance was a little bit more than 86%. Okay, keep in mind here that this project was a proof of concept. Thus, I was able to prove the functionality of this approach, and of course, it can be applied in the same way to assess the health of fruit trees, maize, rice, or any other plant based on the state of the leaves. In conclusion, the system presented is a fully functional one, being able to identify two widespread diseases in the vineyards. The solution shows the potential application of the intelligent system in solving practical issues faced by agriculture producers. Thank you very much for your attention.
All right, so awesome. Now it's time for a quick preview of our upcoming webinar with Microchip on sustainability and smart agriculture, brought to us by Microchip's Wizard of a Make and occasional Hackster guest, Bob Martin. Stick around because we're going to be dropping the links for all these projects as well as the upcoming webinars in the chat and in the video description. Be sure to sign up for the emails. And of course, we're also going to bring our whole live team on for today's event at the end so that we can give you a little farewell message. All right. Right now we've got Bob Martin coming up. And here we go.
Hi there, this is Bob Martin, your Wizard of Make for Microchip, and I'm inviting you to check out my upcoming Impact session on smart agriculture coming up in the first week of November. More details available on this channel, but I wanted to give you a little preview of what's coming up. And it's all relative to one of our focuses, which is the sustainability in smart agriculture, specifically in water conservation. And we've all seen your neighbors' golf courses, public parks watering their lawns when it's raining. So we need to be better about conserving that precious resource. So I am taking a existing design that we've had, which has actually created a lot of interest, both here and in Europe at trade shows, actually worldwide. And this was the Agri IoT board. Oh, I got it upside down. There we go. And this is, as you can see, kind of a self-contained unit where you plug that into the ground, and then there's over here where my finger is, my baby finger is, that's a LoRa radio module, and this was a very well-received design. What I'm doing, or going to be walking you through, is I'm
up-leveling's the wrong word, but I'm changing gears a little bit into using the AVR IoT. This is a board with an LTE modem on it, so now we're moving from LoRa RF infrastructure, which was fine, more over to a cell-based infrastructure. I'm combining that with the standard soil moisture sensors and the air quality sensors all together, and also connecting it to Avnet's IoT Connect dashboard, which is another scalable system. So I'm going to be walking through how I integrated the sensors, some challenges in measuring soil moisture that you might not think of. I'm going to pull that all together, walking through how to add all of this. By the way, all this board, the AVR board, is supported in the Arduino environment. So it makes for easy prototyping for new sensors. So come join me as I walk through the Arduino environment, so hooking up or setting up the certificates for IoT Connect and pulling it all together with some power management. So again, join me, Bob, the Wizard of Make for Microchip. First week in November. Again, details will be coming soon on this channel, and I'll hope to see you there. Thanks a lot.
Sweet. All right. Those are our presentations for today. Thank you so much for joining us. We've got those webinars to look forward to. Be sure to watch out for that email with the links to both webinars as well as all the projects that you saw here today. Our team is also dropping those links in the chat. We're going to get them all on screen in just a second here. I'm also going to update the event recording pages with all these links as well. On our Impact Spotlights page, actually, I've got these projects pulled up real quick as well. Mhm. You can see all of these write-ups in full. And Hackster team, feel free to add yourselves now. On our Impact Spotlights splash page, you can already see the next couple of themes that we have coming up here. If you publish a project around these, you might get featured on the front page and or invited to present at a future event. Feel free to send them also directly to us at impact@hackster.io and at the URL that I'll be showing here on the screen in just a moment. Either way, we'd love to see what you're making and share it with the world. So here is that banner. And Hackster team, feel free to join me on the screen. All
Hey,
right.
team.
I'm dropping Jesselyn in here too. Awesome. Yeah, shout out to all of you folks. Thanks again to Katie for jumping in.
No problem.
Yeah, and Ben for your spot at the start. I
They
love the
changed
cornfield.
shirts. Yeah.
What? Is it the same shirt?
No, it's not the same shirt. But a
Well,
flannel would probably have been better walking out of a cornfield with. So.
You do you.
But no.
And Jesselyn is also killing it on the social front as well. You folks are amazing. Also, shout out to Ginger Zung, who's our community manager, our designer Courtney, who made our beautiful backgrounds, and our whole crew, of course. This is a team effort, and I am so honored to get to work with these wonderful people.
Awesome.
Would any of you like to say anything?
I actually want to add on to that. Awesome team, but also awesome audience. I was in all the different chats and the different areas where we're streaming, and it was great to see the positive feedback and the encouragement. Also love the project, super innovative. And the sponsors are great. Today we have Nordic and Microchip. You guys will have links going out and also emails. Hopefully those events look interesting and something that you may be curious to learn more about. So please jump in and register for those upcoming webinars. The other thing that I'd love to say is that we have secured support for this program for the next 4 months. So this is great. And we're soon to close in on the next 12. So Impact Spotlights are here to stay. So very excited. If anyone wants to know more, please go to the Impact Spotlight landing page. You'll see the titles and the topics for the next 2 coming up. And if you have a project or something that you're interested in that you'd like to surface, or you just like to reach out and talk more about what our plans are for that, please. This is a community-driven event. We would love to surface anything, and if you have a specific spotlight that you would like us to focus on, yeah, please reach out and let us know. And we'd love to have a conversation.
Absolutely. So stay tuned for future episodes. Sign up to submit your own projects. Let me put that banner up again. Yeah, thanks for being part of the community and hack on.
Thanks, everyone.
Cheers.